Okay, day 2, the binomial theorem. Make sure you have your notes out. So we're going to do some vocabulary first. The operation of multiplying a binomial to a specific power, then writing the polynomial in standard form, is to expand that binomial. That's really all it is. And then for every positive integer n, a plus b to the nth power is blah, 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 blah. That is the binomial theorem. We will go more in depth with that. This is the formal definition. You don't necessarily need to know that. It's just good to see. Okay? So, a rectangular array of numbers in which the first and last number is 1. Each of the numbers in the row is the sum of the two numbers above it. That's supposed to say triangular array, not rectangular. But it is Pascal's triangle, because a triangle is not a rectangle. So that should say triangular. So cross that out and put triangular. But that is Pascal's triangle, which is this little triangle that we have below here. So let's just go through this real quick. So the top number on Pascal's triangle is always 1. The top number and all of the sides are always 1. Okay? So the next row, so wait. I want to go back. That top number, that doesn't count as a row. That is technically our 0 row. Kind of weird. It's our 0 row though. Okay? This one is our first row because the second number is a 1. So that's our first row. And on this one, it's still just 1, 1 because the outsides are 1. Okay? The next one, it's 1 on the outside. Then 1 plus 1 is 2, hence why there's a 2 in the middle. And then it's 1 again on the outside. And that's the second row. Okay? I would maybe write that out to the side. Go to the next one. So it's 1 on the outside. Then 1 plus 2 is 3. 2 plus 1 is 3. And then 1 again on the outside. Go to the next row. It's 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1 on the outside. And you keep going. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then 1. One more. 1. And then 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then 1. Hopefully you're getting the gist of it. I'm not going to go through these next two, but this can keep going forever. And you just get those numbers by adding the two numbers that are directly above it. Okay? And this goes on forever. You could infinitely long. We don't have time for that, nor do I ever want to draw the entire thing, because you can't. Okay? So let's do some examples. Let's expand these using the distributive property and see the difference between using distributive property and the binomial theorem. Okay? So first, x plus 3 cubed means we have x plus 3 times x plus 3 times x plus 3. Correct? And then I'm going to multiply the last two x plus 3's together using distribution. So I have x plus 3, and then I multiply the x to the x plus 3 and the 3 times the x plus 3. You end up with x plus 3 times x squared plus 3x plus 3x plus 9. You combine those three x's, you get x squared plus 6x plus 9. Then we have to distribute one more time. So I'm going to distribute the x to that trinomial and the 3 to that trinomial. And I end up with x cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27. Cool? Now we just combine like terms. So we're going to combine our x squareds and our x's. And you end up with x cubed plus 9x squared plus 27x plus 27. And that's it. Kind of a lot of steps right there, right? It's easy to make a mistake in there. So let's do example B. It's basically the same, but we have a 2 instead of a 3, right? So we have 3 of them. We have x plus 2, x plus 2, x plus 2. We're going to multiply the second 2 together, and you get x squared plus 2x plus 2x plus 4. You combine those two x's, you get x squared plus 4x plus 4. Then we're going to distribute again. So we're going to distribute the x, just distribute the 2. So you get x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Combine like terms, you get x cubed plus 4x squared plus 2x squared. Then you have to combine the 4x and the 8x and then the 8. Final answer is x cubed plus 6x squared plus 12x plus 8. Sorry, I went through that kind of fast. If you need to pause it, you can pause and go through and look through this, okay? Let's explore the connection between the Pascal's triangle and the expansion of these binomials, okay? First, what is anything to the 0 power? It is 1. Anything to the 0 power. You could have a huge, huge number, raise it to the 0 power, it's going to equal 1. So that's 1, which is what the 0 row of our Pascal's triangle is. It's just 1, okay? A plus b to the first power is 1a plus 1b, or just a plus b, which those coefficients are the same as our first row, 1 and 1, right? Let's go to a plus b squared. You can square that out if you want to, or you can just trust me. It is 1a squared plus 2ab plus 1b squared, which is our second row's coefficients, 1, 2, 1, okay? The third row, again, you can expand that out if you want to, or you can just trust me. But it's 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed, which is the third row's coefficients, 1, 3, 3, 1. So if we go to the fourth row, it's going to be the same thing. Those coefficients are 1, 4, 6, 4, 1, which is the same as the fourth row. Okay? Again, if you want to expand this out so that you can discover this for yourself, go for it. More power to you. That's awesome. You don't have to, though. You can trust me if you want to. Okay? So let's do some examples. Except we're not going to do this example. We might do it in class later. I haven't decided. We're also not going to do these examples. Okay? We're going to do these examples. So I want you to go to example 5 on your notes. And I want you to take really, really good notes on this. It's super important. If you don't take good notes on this, you might get confused. And this is one of the harder concepts this unit. Okay? So first, this is to the 5th power, which means I'm going to draw 6 boxes. I have a thing with boxes. I really like boxes. So it's always one more than the power. The boxes just help you keep it organized. Okay? And then we're going to use x as our first term because it's the one that comes first. And we're going to use 2 as our second term because it's the one that comes second. So x is our a term, 2 is our b term. And let's just put those in the boxes. So I have x and 2, x and 2, x2, 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 x2. And all the boxes in there in parentheses so that they're separate from each other. Okay? Now we need to deal with the exponents. This binomial is raised to the 5th power, so we're going to start with the 5th power on the x. Okay? So it's x to the 5th. And then we're going to count down. So it's going to go x to the 4th, x cubed, x squared, x to the 1st, and then x to the 0 power. Okay, now we need to deal with our 2. The 2 needs to be raised to an exponent 2. We ended at 0, so we're going to start back at 0. So it's 0, and then we're going to count up. 1, 2, 3, 4, 5. Okay, pretty straightforward so far. And now that binomial is raised to the 5th power, so we have to use Pascal's triangle somehow. We're going to use it, because it's to the 5th power, we need to use the 5th row, which is the 1, 5, 10, 10, 5, 1 row, because it's 5 as the second number. It's the one with 5 as the second number. And now we're going to put these numbers in front of the terms we already have in the boxes. So we're going to put the 1 there, then the 5, then the 10, then the 10, then the 5, then the 1. Okay? We're almost to the part where we can just simplify. Except, let's see, what is anything raised to the 0 power? We just went through this. It is 1. So we can cancel out anything that's raised to the 0 power, because when you multiply something by 1, it just stays the same, correct? So we have 2 to the 0 power, and we had x to the 0 power in the first and last boxes. So I'm just going to put an x through those, and I'm going to get rid of them, because I don't need them. It's just extra weight, okay? And now we're just going to simplify each box. So in this first box, 1 times x to the 5th is just x to the 5th. The second box, we have 5 times x to the 4th. 2 to the 1st power is 2. Okay? The next box, we have 10 times x cubed. 2 to the 2nd power is 4. The third or 4th box, we have 10 times x squared, and then 2 to the 3rd power is 8. Okay? The 5th box, it's 5 times x to the 1st, which is x, and then 2 to the 4th is 16. Then the last box, 1 times 2 to the 5th. 2 to the 5th is 31, so it's just 31. Now let's just finish simplifying these. So 5 times 2 is 10, so that becomes 10x to the 4th. 10 times 4 is 40, so that's 40x cubed. 10 times 8 is 80, so that's 80x squared. And then 5 times 16 is also 80, so that's 80x. And then a binomial is a sum, so the last step is to just add all these terms together. So it's going to be x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared. That's supposed to be squared. I don't know why I do this in every video. That's supposed to be a squared. And then plus 80x plus 32. And that's your final answer. Except for that 80x cubed should be a squared. So make sure you write that as a squared, not a cube. Okay? I even did it wrong right there. Of course I did. Okay, let's do example B. So first, there are 3, this is raised to the 3rd power, so I'm going to draw 4 boxes. And I'm going to put 2x and 5 in each box, right? Now I'm going to deal with the powers. So it's raised to the 3rd power, which means I'm going to start the 2x at the 3rd power. So it's going to go 3, count down, 2, 1, 0. You end at 0, so I'm going to start back at 0. So 0, 1, 2, 3. Now I need to use Pascal's triangle. This is raised to the 3rd power, so I'm going to use the 3rd row. So it's 1, 3, 3, 1, and I'm going to put those numbers right in front. So 1, 3, 3, 1. Now what is anything to the 0 power? It is 1, so I'm going to cancel those ones out, and they're gone. Then the last step is to just finish simplifying this out. Now, 1 times, let's do what 2x cubed. That means we have 2x times 2x times 2x. So 2 times 2 times 2 is 8. And then x times x times x is x cubed. So we have to cube both terms there. Okay, that's why that's 8x cubed and not 2x cubed. Okay, this next one is 3. 2x squared is 4x squared, and then times 5. The next one is 3 times 2x to the 1st power is 2x, then 5 squared is 25. Then the last one, 5 cubed, is 125. I'm going to finish multiplying these out. So 3 times 4 is 12. 12 times 5 is 60, so 60x squared. And then 3 times 2 is 6. 6 times 25 is 150. And then we just finish adding these out, so it's 8x cubed plus 60x squared plus 150x plus 125. And then you're done. Okay? All right, I want to go back for a second. The reason we do the binomial theorem is because the only other way we could expand these is to multiply them out multiple times, like we did the first time when we used distribution. And with 3, when it's raised to the 3rd power, it's not that bad, but once you go to the 4th and the 5th, it gets super messy, and it's just hard to keep track of everything. So believe it or not, this is the easier way to do it, okay? So for these ones, when finding a specific term, you need to set it up as if you're finding the whole expansion and then simplifying that specific box. So like on example 6, you would write everything out, and then you would just go to the 3rd box and simplify down in that box, okay? I want you to try and do these. We're going to go over them in class. It will be super beneficial to you if you do them, okay? So I will see you guys tomorrow. Remember to take the quiz, and please come to class with any questions that you have. I know this is a more difficult concept, so you'll probably have questions. Make sure you ask them tomorrow, okay? I'll see you guys in class.